Okay, so you've definitely heard this before, probably 1,000 times. But did you ever stop to think that the sound of a passing siren, well, that it holds one of the biggest secrets to understanding the entire universe? It all kicks off with this really simple, super familiar change in sound.
You know exactly what I'm talking about, right? An ambulance is racing towards you, and its siren is just screaming this high, urgent pitch. And then, the second it passes you, boom, the sound just drops. That classic neom effect, that's not in your head. And trust me, the driver isn't messing with any buttons. So what in the world is going on?
Well, that's the exact same question someone, let's call her Neha, had. Just picture it. She's standing on a train platform, and this high-speed train just thunders past, its horn blasting. And right there, in that totally normal, everyday moment, lies a clue. A clue that connects our little world right here to the absolute farthest reaches of space.
So, let's start right there. Let's solve this little train horn mystery. It's a puzzle that starts with our ears, but you'll see, it's going to end with our eyes looking up at the stars.
So what Neha actually heard was like a story told in two parts. As the train was racing toward her, the horn sounded really sharp, super high-pitched. But then, the instant it flew by and started moving away, that pitch just tanked. It got way, way lower. It's the exact same horn playing the exact same note, but our ears are telling us it's two completely different sounds. Weird, right?
Okay, so to figure out why that happens, we've got to put on our detective hats and crack the sound wave code. The secret to this whole thing is hiding in the invisible waves that are literally traveling through the air all around us.
Now, there's a fancy scientific name for this. It's called the Doppler effect. And yeah, the official definition can sound a little textbooky. The change in wave frequency due to relative motion. But don't let that throw you. The actual idea behind it is super simple.
Here's a way to think about it. The train's horn is just constantly sending out sound waves, right? Kind of like ripples in a pond. Well, when the train is moving towards you, it's basically catching up to its own sound waves, scrunching them all up together. And then when it moves away, it's stretching those same waves out behind it like a rubber band.
All right, so here's the play-by-play. As that train comes closer, it's squishing the sound waves in front of it. That means more waves are hitting your ear every second, which increases the frequency. In our brains, we hear that high frequency as a higher pitch. Simple. Then, the moment it passes, those waves behind it get stretched out. Fewer waves hit your ear per second, the frequency drops, and we hear a lower pitch. And here's the kicker, the most important part. The horn itself never changed its tune, not once. It's our perception of the sound that changes, all because of motion.
Okay, so mystery solved. We figured out the train horn. But this is where things get really wild. We're about to take this idea and make a giant leap. From the world of sound, all the way to the world of light.
Because here is the amazing part, the part that makes a simple train horn truly cosmic, the Doppler effect. It's not just for sound. It's a basic rule of physics that applies to all kinds of waves, and that includes light waves. And once scientists figured that out, oh man, it changed absolutely everything.
And the comparison is just perfect. Think about it. When a star or a galaxy is moving towards us, its light waves get squished together. This shifts the light towards the high-frequency blue end of the color spectrum, and astronomers call this blue shift. Now, what if an object is moving away? You guessed it, its light waves get stretched out, shifting them toward the low-frequency red end of the spectrum, and that we call redshift. It is the exact same idea as the train horn, just playing out with starlight instead of sound.
So what does this mean? What can we do with this knowledge? Well, it means astronomers can basically start listening to the universe. They can analyze the light from distant stars and galaxies in the very same way Neha was listening to that train horn.
This simple rule is like a cosmic speed gun or a decoder ring. When astronomers look at a faraway galaxy and see its light is blue shifted, they know, for a fact, it's moving towards us. And if its light is red shifted, which, by the way, most of it is, they know it's moving away from us. And this isn't just some clever party trick. This is literally how we map the motion of the entire universe. And all of this brings us to this one beautiful, grand connection, a single, elegant rule that ties a noisy train station right here on Earth to the silent, mind-boggling vastness of space.
This is the aha moment. The exact same physics that explains why a train horn changes pitch is precisely what allowed scientists to discover that the light from almost every distant galaxy is redshifted. What does that mean? It means they are all moving away from us,
And that wasn't just some minor finding. No way. That was the first massive, undeniable piece of evidence that our entire universe is expanding.
Just stop and think about that for a second. The simple physics happening on a train platform is the very same physics that allows us to paint the biggest picture imaginable, the picture of our entire cosmos. It's one single universal rule connecting something totally ordinary to something absolutely magnificent. The sound of a horn and the dance of the galaxies.
It really makes you wonder, doesn't it? I mean, if the secret to the expansion of the whole universe was hiding in plain sight, in the sound of a passing train, what other huge cosmic secrets are out there, right in front of our noses, just waiting for one of us to ask the right question?